the equilibrium of a system is by manipulating the temperature. We can make the temperature of the system go up by adding heat to the system, like putting the system on a hot plate, or we can make the temperature of the system go down by putting it in a chilling chamber like a refrigerator or a freezer. Now, in a chemical reaction, okay, we will not see temperature in the reaction. So what we need to understand is that when we cause a change in the system, we are manipulating or stressing the heat. So we manipulate the temperature, and the result is heat. Okay, so like before, we can either cause an increase in the temperature or a decrease in the temperature, and where we associate this in the reaction is where we see mention of the heat energy. So take a look here. So we have N2 plus 3H2 forms 2NH3 plus heat. So if I add, or if I cause an increase in the temperature, that means in some way, shape, or form, I added heat. I heated the system. Now, heat is shown to be in this reaction on the product. So the stress is a product. The stress is an increase in the temperature, which means heat has been added to it. So if it's an addition, you're going to shift away. And this time, for this reaction, if you shift away from the stress, that means that the system will shift to the left. Let's take a look at the second one down. So once again, we see heat is on the product side, and there is a decrease in the temperature. So that means that it has been removed. So the stress is still a product, but this time the temperature dropped, which removed heat from the system. So if something's removed or taken out, you shift towards the stress. So in this process, if you're shifting towards this stress, then the system will shift to the right. So let's just go through the descriptors of why the system will shift to the left or to the right. So here we go. So the temperature of the system was increased, meaning heat was added. So now there's too much heat. So now there's extra heat in the system. How does the system deal with the extra heat? The extra heat has to be used up. So the system uses the heat by absorbing it. So whatever is on the same side as the extra heat is the structure that has to absorb it. So this means that the reverse reaction, is favored, meaning that the products will make more of the reactants. So in this case, NH3 absorbs the heat, and the result is it decomposes into the reactants. So it decomposes into the reactants. So NH3 is used. So the amount of NH3 present in the system will decrease by endothermically absorbing. So this is used. And as a result, it decomposes into the two elements. So the concentration of hydrogen will increase and the concentration of nitrogen will also increase. The next example is that the temperature of the system was forced to decrease, and you do that by removing the heat. So now in this system there's not enough heat. So the heat has to be replaced. So the system has to replace the heat. And the way that the system replaces the heat is using a reaction that will release it. So it needs a reaction that will release the heat. So in this case, we're shifting to the right. So the forward reaction is favored. The reactants will form more of the products, and as N2 and H2 react to form more of the products, it releases the heat. So the reactants will form the products. So N2 and H2 will release heat when they make NH3. So N2 and H2 are being used in this reaction, so their concentrations will decrease. As they react, more NH3 is formed, so its concentration will increase, and the heat that was removed is now being replaced.